Consider the following Kirchoff's law circuit problem. We are given certain pieces of data. For example, we are given the current flowing on the top branch and the two side branches. And we are asked to find the power dissipated by the 3 ohm resistor in the middle. We are also asked to deduce the voltage of these two batteries and the value of the mystery resistance R. So this is a typical multi-loop Kirchoff law problem. Now, first of all, the KCL rule can be used. The current law says the sum of all the currents appearing at a node must be 0. 3 amperes comes this way, 5 amperes comes this way. They're going to join up and become 8 amperes. So we certainly know that 8 amperes must flow through the 3 ohm resistor. And as a result, the power dissipated can be found almost instantly from the formula for power dissipated, which is I squared times R. In this case, I is 8 amperes, so that's 8 amperes squared times 3 ohms. Now that's 64 times 3. 60 times 3 is 180, so that's 192 watts. Now for parts 2 and 3, you have to apply KVL. KVL is the statement that the sum of the voltages around a loop is equal to 0. Now actually, we are not done with KCL yet, because let's think about this. 2 amperes comes down and becomes 3. How is that possible? It's impossible unless 1 ampere was coming this way. So 1 plus 2 equals 3. So we already know that there must be 1 ampere in this branch. Now 8 amperes is going up and it has to go somewhere. 1 ampere goes left. That means 7 amperes has to go to the right, because 7 plus 1 equals 8. Now let's think about this one now. 7 amperes becomes 5 amperes and then 2 amperes goes there. Now let's make sure this is all consistent. The 2 amperes comes, meets up with the 1 ampere and becomes 3 amperes. And indeed 2 amperes is what we have there. So as a matter of fact, we need not even have been, well, actually, I'll take that back. We do need the 2 amperes there to get the 1 ampere here. So this is consistent. Everything looks good now. All we need to do is to find the voltages. Well, that's done by choosing loops. Now, your loops can be chosen in any direction. So there's one loop that I can choose. Let me choose this loop to be in the clockwise direction, like that. And let me choose this loop to be in the counterclockwise direction. So this is completely arbitrary. You don't need to follow any convention or rule by any means. And let the third loop be this one. Hopefully these 3 loops will suffice to find everything that we need to find. Loops 1 and 2 will tell us about the nature of the EMF, and then loop 3 can be then used to find the mystery value of the resistor. And there's a verification loop that you can use which goes around the entire perimeter if you feel like doing that. If we have some time left, I'll also do the verification loop just to make sure everything hangs together nicely. So let's write the loop equations next. I always like to start from the battery. So starting from the battery, I'm climbing down in potential, so I get negative E1. I'm meeting 8 amperes, so I must be going uphill. So that gives me plus I, which is 8, times resistance, which is 3 ohms. And then I'm again meeting 3 amperes coming my way, so I must still be climbing. So I get plus 3 amperes times 4 ohms must be equal to 0 because I end up where I started. Now that's a really nice thing because we can immediately find out what E1 is. E1 is equal to 8 times 3, which is 24 volts, plus 3 times 4, which is 12 volts, for a total of 36 volts. So we have found, let's box these answers up so we know that we're making progress. So just from loop 1 that falls out. From loop 2, let's see what we can get. If you look at loop 2, I'm actually going from the higher potential to the lower potential again because of the direction of I chose. So that gives me negative E2. And I meet the current, so I get as before 8A times 3 ohms with a positive sign. And then I again meet the current, so I must be still climbing. So that gives me plus 5 amperes times 6 ohms. And then I end up back at the battery, so that's 0. So in exactly the same fashion, I get E2, which is 8 times 3 plus 5 times 6, or 54 volts. So that's another answer. That's part 2. We have determined the voltages E1 and E2, or the EMFs as they say. For the third part, let's choose loop 3. Loop 3 is a loop that starts here and stays within the top part. So let's start from some battery. How about battery E1? You're going down in potential, so that gives me negative E1. And then battery E2, you're going up in potential, so I get positive E2 because I'm going from negative to positive. I must be climbing the hill. Over here, I am going in the same direction as current, which means I must be descending. So I get minus the resistance, the current, which is 2 amperes, times the resistance R, which we do not know, back to where we started. So that's equal to 0. So this tells me I'll take the 2 amperes times the resistance to the other side. So I get 2 amperes times the resistance is equal to E2 minus E1. Well, E2 is 54 volts and E1 is 36 volts. That's 18 volts. Now, R then will be 18 volts divided by 2 amperes, which means R is 9 ohms. So we have found everything we need to find in this problem. The only thing that remains to be done is to verify if all this hangs together nicely by using the verification loop. That is something I highly recommend because it does not use much of your time and it gives you a feeling that you've done everything right. So let's do the verification loop 4 to check your results. I can go anywhere I want. So how about there's no battery involved here. So if I go like this, I'm going to get negative 3 amperes times 4 ohms. That's the voltage, and I'm dropping because I'm going with the current flow. I must be descending. I'm meeting it, so I must be ascending again. So I get plus 5 amperes times 6 ohms. And here I'm going in the same direction as the current flow, so I must be again descending. So I get negative the current, which is 2 amperes, times the resistance, which we have found here already. So that's 9 ohms. And the hope is that this is 0, because that's what KVL requires. So this tells me that's negative 12 volts plus 30 volts minus 18 volts is equal to 0. And indeed it is, because 18 plus 12 is 30 with a negative sign, and 30 with a negative sign plus 30 becomes 0. So in this way we have solved everything that we need to solve in this problem.